Okay. Yeah. Hello everyone. So welcome to your class on calendar. Okay. There are power cuts here. Somehow we have been able to manage. Okay. Now let's get started. The classes will be fine. Now the topic for today is calendar. Many people find it a little tricky, so we'll take good time with it. Okay. It is a very methodical chapter. Okay. There are proper methods how you should be doing things here, and if you follow them then you can get to the answer. Okay, now every year there is around one question from this chapter. If you see from 21, 22, 23, 24, 25, every year you find one question. Okay, sometimes mixing of concept from some other chapters is also used. Okay, now first thing, what you know about a year. What you know about a year, that a year has 365 days. In the general sense this is correct. Now this is what the world started with when they started forming calendars. Then they found out that after a few years they started finding out some discrepancies. For example, let's say you are habitual of seeing, let's say, Holi during the season when flowers are there and everything is there, correct? So it is like the Vasant season that you call. Now what used to happen, that after some times it started turning that Holi is in summers. Similarly, some other festival became like this. Now why something like this was being observed was because the day or the time of revolution of earth is not exactly 365 days. It is actually approximately 365 1 by 4 days. Okay, it is actually 365.24 like this. So now they started using 365 1 by 4, but this is very difficult to count in terms of number of days, correct? This is like 6 hours. So counting this does not make much sense. So then they came up with a solution that we know as leap year. That is, on the year 1 we will have 365 days, in the year 2 also 365, in the year 3 third is also 365, but the fourth year, every fourth year we will have 366 days, correct? So if there are 366 days, you can see 1 by 4, 1 by 4, 1 by 4, 1 by 4, 4 times you are adding 1 by 4, so you get one extra day which is calculated in this leap year. Understood? So this is how the concept of leap years came. That what is the need for a leap year? That the number has to be divisible by 4. Okay, this is the requirement. Now after few years they found out that actually it was 365.24 something something, so there was still some error. Now that error started appearing when they saw in terms of centuries. So then they came up with a new concept, that for century year, for a century year, what are century years? For example, 100, 200, 300, 1800, also you can count 2000 like this. Okay, 400, 1800 like this. Now what they found, that what we can do is we will stop counting the century years as leap years except for when they are divisible by 400. So 100, even though is divisible by 4, which is the general rule for leap year, we won't count 100 as a leap year. Similarly, we won't count 200 also, 300 also, but 400 will count. That is for a century year they change the rule to not divisibility by 4, but it has to be divisible by 400. Understood? So this is the concept, that how you find a leap year. So if it is a non-century year, normal year, what you do? You divide it by 4. If it is divisible by 4, it is a leap year. But for a century year, you will always divide by 400 to see this. Understood? Yes, Nandini, good afternoon. Then now once you get leap year and the concept of leap years, now you see this. If today is Monday, then what is the day after 7 days, 10 days, 61 days? This is the question. Okay, now if today is Monday, let's say today there is Monday, I am counting it as first. This is the What is the date today? Today is 1st of April. Very nice. So this is 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. These are the 7 days in a week. Correct. So I take it like this. Now see. Now, so this is Monday, this is Tuesday. Correct. Then Wednesday, Thursday, Friday, Saturday, and Sunday. Correct. Then on 8th, what you will have? On 8th, you will again have Monday, then on 9th, Tuesday, then 10th, Thursday, then 11th, you will have Friday, and it goes on. Now, the question is what? The question says, if today is Monday, that I have already taken, then, 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 what is the day after 7 days? After 7 days, what is the day? So, if you look for after 7 days, so 1, 2, 3, 4, 5, 6, 7. What day you get to? You get to Monday again. So after 7 days, what is the day? It is actually Monday again. Now, why is it so? Why you're getting Monday again? So the thing is that how many days do we have in a week? We have 7 days in a week, correct? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So there are 7 days. Now, if I add 7 days on any date, the day remains the same. For example, today, let's say today is Monday, then after 7 days, okay, what day again I'll have? I'll again have Monday. Then if I similarly count, can you tell me that after 14 days, what will be the day? Let's count it. So this is 11, then 12, 13, 14, 15. So this is again Monday, 16, this is Tuesday, like this. Saturday, Monday, Tuesday, Wednesday. So this is Wednesday, Thursday, Friday, Saturday, Sunday, and Monday, Tuesday again. Now if I count after 14 days, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Again I get Monday. That means from this what I understand, that I can add any multiple of 7 and the day does not change. The day does not change if I add multiples of 7 to it. This you understand? So if I add 7 days, if I add 14 days, 21 days, the day won't change at all. Correct? Now, if this is so, then for any other day also, for example, if we are talking about after 10 days, then also I should not worry about these 7 days, because after 7 days, it is the same repetition. Correct? So 7 days I don't need to count. What I only need to consider is what remains after 7 days. And that is what you know as the concept of remainders. Now see, if I were counting after 10 days, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What I got? I got Thursday, correct? Now if I do it using remainder method, what I'll do, so there are 10 days, I divide this by 7. I divide 10 by 7. What is the remainder? What is the remainder? The remainder is very clearly 7 ones are 7. What remains? 3. So that means 3 is the remainder. Now as we understood, 7 does not matter. So we don't worry about the quotient whatever we are getting. We only care about the remainder. Correct? So that means 3 is the remainder. What was the day? The day was originally Monday. So I will simply add Monday to this. Now what is the day? What is Monday plus 3? Monday plus 3 is what? Tuesday, Wednesday, Thursday. So that means the answer is Thursday. Understood? Can you find out for 61 days? Find it out. That after 61 days, what will be the day? What you will have to do? Divide 61 by 7, get the remainder, and that you have to add in Monday. That's the only thing. Find it out. Okay, Dheeraj. Yes, Shweta. Yes, Dheeraj. Yes, Dream 1772. Okay, now what we are doing? Simple thing. We are again taking whatever is the number of days, that is 61. I divide this by 7. 61 by 7, what is the remainder? Now, table of 7 is very important in this chapter. 7 8s are 56. Correct? What remains? What remains? 5 remains. So, here you got 5 as a remainder. This is clear. Now if you got 5 as remainder, what you have to see it from? You have to see it from Monday. If today is Monday, so I add Monday here, or I add 5 days in Monday. Monday plus 5 is Tuesday, Wednesday, Thursday, Friday, Saturday. So answer becomes Saturday. Got it? Simple. Okay, so this is how we calculate if the question is after 7 days, after these many days. You divide it by 7, get the remainder, add that many number of days to whatever day was given to you. Now, now understand this concept. This is after x days if it is written, this is equivalent to on x minus 1th day. Now, this confuses people. Okay, now instead of asking if today is Monday, I say if first day of the month is Tuesday, then what is on the 22nd day? Or let's say, yeah, 22nd day. Now it is talking about, it is telling first day of the month is Tuesday, then what is on the 22nd of day? Now some people, what they tend to do, because they are in the habit of using that same after method, so they will do what? They will say 22 divided by 7. What is the remainder? Remainder is 1. So then in 1 they will add Tuesday, and they will say that the day would be Wednesday. This is wrong. Why this is wrong? Because this is talking not after these many days, but on the 22nd day. Correct? So this is actually not correct. Now how do you correct it? So understand this, that always remember after x days is equivalent to x minus 1th day. A very good example of this can be this. See, you know about Navratri, correct? Now you also know about Dashera. Now you actually say this also. Now I say that today is first day of Navratri. Today is first day of Navratri. Now after 9 days we have Dashera. Correct? Today is first day of Navratri. After 9 days, what we'll have? We'll have Dashera. Correct statement? Sounds very nice to yours. Okay. Now the other way I say this is that the 10th day of Navratri, 10th day of Navratri, or on the 10th day, what you have? You have Dashera. Isn't this the same thing? Correct. So that means after 9 days is equivalent to 10th day, or x days if you are talking about, this is equivalent to x minus 1th day. Understood? Okay. Now, sorry. This is plus. Yeah. So after 9 days is equivalent to on x plus 1th day. Okay. Minus, no, not minus, plus. After 9 days, let me write an example also. So this is after 9 days is equivalent to on 10th day. So whenever you get a question in which it is written that what will be on 22nd day, first thing what you do, you subtract 1 from it to convert it into after form. So this becomes what? 22 minus 1, that is, this is equivalent to after 21 days. After 21 days. And after 21 days, you know what you have to do? This you already know. 21 divided by 7. What is the remainder? Remainder is 0. So on 22nd also, you will have the same Tuesday. Then the process becomes simple. So whenever you get some nth day, what you do? You just subtract 1 from it and use the after x days same formula. Okay. Now, let's do this. This is another way of writing the question. So it says, what will be the 5th day from 21st of this month? Okay. Now, so if you take 21, 5th day from this, okay, this is not the first day. From this, what will be the 5th day? So I simply have to add 5 to it. It becomes 26th. Now the question is, 3rd day of the month is Monday. So on 3rd it was Monday. The question is, on 26th, what day you will have? Fairly simple. If 3rd is Monday, 26th is what? Very simple. You divide it, 26 minus 3. 26 minus 3 is the time range. So 26 minus 3 becomes 23. 23 divided by 7 gives you the remainder. What is the remainder? The remainder is very clearly 2. Correct? The remainder is 2. Now what you have to do? So you have to add this to Monday. Correct? So this becomes Monday plus 2. Monday plus 2 is what? Tuesday, Wednesday. So answer becomes Wednesday. Answer is C. Yes, Anurag. Yes, Neelam. Okay, then. So these are some simple questions. Now we get to the main concepts. You can do one more actually. Yeah, you can try this also. It's not visible. I'll zoom it up. Options, I'll write it. So A means statement 1 is sufficient. B is statement 2 is sufficient. C is both together are sufficient. And D is no, none or both not sufficient. Both not sufficient. So these are your options. Try to do it. It is fairly easy. The question is, what day is the 14th of the given month? The last day of the month is Wednesday. The third Saturday of the month was the 17th day. Statement 1 से नहीं पता चल रहा. Yes, you should at least give time, Anurag, to read this part. That is, what is the day on the 14th of the given month? This will give you an idea that what kind of question is this. Okay, the length of the option, don't go by the length of the options. As I told you in last class also, that I usually just reduce the size of it. It is actually written statement 1 is sufficient, statement 2 is sufficient, that's it. Now if you look at this is not very big. So you can just read the question, identify you can do it or not, or and then move forward. Don't go just by the length, that because it is long it must be tough. Yes, for Kirish. Now you see this, it is asking you what is the 14th of the given month. So it is asking you what is on 14th. Correct? While what it gives you, so it gives you first statement. the last day of the month is Wednesday. Now, can I know anything by the last day? Can I know anything by the last day? No. Why? Because the last day of the month can be 28th, correct? If it is February, it can be 29 also. If it is a leap year in February, it may be 30. For example, if this is April or November, it may be 31 also if it is January or December. So now what date is exactly Wednesday? So if 28 is Wednesday, the answer is different. If 29 is Wednesday, answer is different. 30 is Wednesday, answer is different. So this is not giving me the answer. Then the third Saturday of the given month was the 17th day. So now this is very easy. That on 17th what you have? 17th, third Saturday does not matter. On 17th you had Saturday. Then what you had on 14th? You can just minus 3. That's it. So if you had Saturday, then what was on 16th? 16th was Friday, 15th was Thursday, and 14th would have been Wednesday. Of course, you did not calculate this, but this is an enough statement. And that is why the answer is B, that is statement 2 is sufficient. Fine. Yes. Now we get to the two major parts of this. This is the most important part of this chapter. That is finding real day on a date. For example, I give you some random date. Let's say 11th of August 2093. Now, this you will learn that how do you find the day on 11th of August 2093. Okay, so any random date is given to you of past, present, future, whatever. You will be able to calculate day on that day. This they have tested 3-4 times UPSC. Now, but before you can do this, you have to learn some basic concepts. Now, this is the first concept, that is number of odd days. Now, first thing, see, odd days, you will find this written in books everywhere. So odd days is nothing new. Odd days is simply remainder when any time range is divided by 7. Okay, what we were learning as when we were dividing it by 7, we were getting the extra days, correct? And then we were adding it to Monday, Tuesday, whatever day was given. Now that has actually a name called odd days. That's the only thing. So number of odd days is remainder when divided by 7. Now, in a normal year, how many odd days are there? How do you calculate this? Normal year, how many days? 365 days. I divide this by 7 to get the remainder. This goes 5 times minus 35. 1 came out here and 5 I brought from up. So this becomes 15. Goes 2 times minus 14. What I get? 1. This one is what? This one is remainder. But when you divide any number by 7, the remainder that you get is actually equivalent to what? This is actually equivalent to number of odd days. Understood? Actually 364 is a multiple of 7. 364 is a multiple of 7, and that is why 365 leaves remainder 1, and the leap year, that is 366, will leave remainder 2. So how many odd days for a normal year? 1, and for a leap year it will be 2. Correct? Again you will have 366 divided by 7, you will get 2 here. This is fine. Now, so this is for years. If it is normal year, we count 1 odd day. Leap year, count 2 odd days. Then now let's see for month. See, for month we need not do much. There are some tricks and all to remember the number of odd days in a month. I don't recommend them. What you have to do, essentially, what is the nearest multiple to all these months? So basically, month will be of the size of 28, 29, 30 or 31. Correct? Nearest multiple in all these cases will be what? 28. Correct? So if I take January, for example, January is 31 days. Now I divide 31 by 7. What is the remainder? 31 by 7. 28 is the nearest one. Remainder is 3. So essentially, I can just subtract 28 from the number of days that a month has. That gives me the remainder. Here also 31 minus 28 is 3, which is the remainder. So here the remainder is 3. Feb in a normal year is of 28. 28 minus 28 0. But in a leap year it will be 1. Correct? 29 minus 28 1. Similarly, March will be 3, April will be 2, May will be 3, June will be 2, July will be 3, August will be 3, then September again 30 days, so 30 minus 28 2, then October 31, so this is 3, then 2, then 3. You need not remember it using any trick, nothing. You can just subtract 28, you will get the answer. This you can do it in your head while writing. Okay, now if you don't remember this, that how many days are in a month, if that you don't remember, then it's fine. Find a way to remember that for your life also. Okay, so this is January to December. Okay, this gives you the number of odd days. Now this is the question, just a very simple question. Try to think. If 1st January 1996 is Sunday, find the number of Sundays, Mondays, Tuesdays, etc. in the entire year. One hint I can give you, that every year has 52 complete weeks. This is your hint. Tell me how many Sundays in 1996 if 1st January was Sunday. Okay, see, now first thing you observe, 1996, is it divisible by 4? Is it divisible by 4? Yes, 96 is divisible by 4, correct? 24 fours are. Okay, now if it is divisible by 4, this is a leap year. If it is a leap year, it has 366 days. Clear till here? Now, if it has 366 days, how it will be divided? So 366 days are in total. Now, if you remember, a leap year has 2 odd days, but 52 weeks will be completed for this also, correct? So 52 complete weeks are there, correct, plus 2 more days. Now what does complete week mean? One complete week means what? All the days have been covered, correct? So Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and you have completed all the days. So 52 complete weeks are there. So that means every day you take Monday, you take Tuesday, you take Wednesday, Thursday, Friday, Saturday, Sunday, all are at least 52 times. This is fine, but some of them will get one more extra. Now these 2 more days will be what? If it starts with Sunday, then can you feel that 364 is a multiple of 7, correct? So if I say, if 1st January is Sunday, after 364 days, what is the day? After 364 days, what is the day? The same, because this is a multiple of 7. 364 is a multiple of 7. So that means that the 365th day of the year will be again Sunday. Now if 365th day is Sunday, then 366th day is actually Monday. So the answer becomes how many? Sunday, Monday, Tuesday, Wednesday, whatever. So Sunday and Monday, these are 53 in 1996. But if you talk about any other month, Tuesday, Wednesday, Thursday, or any other months, they are 52 times only. Understood? Yes, Neelam. Then now we get to this part, which is finding a real day on a date. Now let's try to find out. Let's find out for our republic. Oh, sorry, Independence Day. 15th of August 1947 was which day? Huh? Do you remember this as a GS question also? Which day was it? 15th of August 1947. 15th August 1947. Okay, now we'll find it out. If we don't know, we'll find it out. So basically 15th August 1947. Now, first thing, how do we reach here? So for reaching this, you need to understand one concept, that is of the number of odd days in a range. Now, number of odd days in a range, understand it like this. So basically, if I ask you that from the first to 100 years, from the start of the calendar till 100 years, what is the number of odd days? What is the number of odd days from 1 to 100 years? Just see this. Okay, I'll only do it. Now, from 1 to 100 years, how many odd days are there? Now, this you can feel it like this. So, if I talk about 1 to 100, how many leap years do I have? Correct. So, the fourth year would have been a leap year. The eighth would have been a leap year. It goes on till 96. 100 is not a leap year. Why? Because century year must be divisible by 400. So, I am counting from 0, 8, 12 till 96. How many numbers will I get? That will be leap year. Simply if I am going till 96, it will be 96 divided by 4. Correct? If you have to count till, let's say, 20, how many leap years are there in the first 20 years? So what are those? 4, 8, 12, 16, 20. So ultimately you could have taken 20, divided it by 4, and the answer was there. Correct? So here also, because 20 divided by 4 gives you 5 anyway. So here also I take 96 divided by 4. What do I get? 24. So that means 24 leap years were there in first 100 years. Correct? If 24 were leap years, what were the other years? They were normal years. Correct? So that means in this first 100 years, I have 24 leap years and 76 normal years. Correct? Now, how many odd days does a leap year have? Leap year has 2 odd days. Correct? Remember this. So, how many odd days I got from here? 48 odd days. And normal year has only one odd day. So, this is 76 odd days. Then, total number of odd days becomes what? Total number of odd days becomes 48 plus 76. 48 plus 76 will be what? 124 days. Correct? Correct. So you are adding 76 and 48. Correct. 4 goes there. And 124 is what you get. This is the number of odd days. Correct. Now, but this is not what I like. Why? Because if the number of odd days that I remember is usually less than 7. Then I am able to add it immediately and it gets me the answer. Now here also 124 days is not of much use. What is of use? When you divide this by 7, whatever is the remainder, that only will change the day. Adding 7 does not matter. So I will again divide this 124 by 7 and find out the remainder. So 124 divided by 7, what is the remainder? Let's divide it here. So 124 divided by 7 goes one time, minus 7, 5 remains, comes here 54. This goes how many times? 7 times. So minus 49, what remains? 5. So how many odd days I really have? I have 5 odd days. This you understand? So that means in the first 100 years, how many odd days I had? I had 5 odd days. Correct? Everybody clear? Yeah, this is a different classroom, Nandini. Okay, okay. Then next. So this is first thing, that from 1 to 100 years, you have 5 odd days. Correct? Now see. So 1 to 100 years, I got 5 odd days. Now similarly, if I do for 1 to 200 years, the answer actually comes to be 3 odd days. Then if I do for 1 to 300 years, it comes out to be 1 odd day. And if I do for 1 to 400 years, it comes out to be 0 odd days. This you can simply do by same process that we followed: number of years, number of leap years, number of normal years. Now I'll tell you one more better way of calculating this. Now see. So number of odd days, this is the formula that we usually use. Number of odd days is equals to, see, every year, whether leap or normal or whatever, will have at least one odd day. That you understand? Correct? Every year has at least one odd day. Leap year has one extra. So why not just write here number of years in range. It does not matter what kind of year it is. Every year has at least one. So this gives me that. Then I will add number of leap years. Why? Because leap years will have one extra. So plus number of leap years. Understood? So this is the way. Let's do the same. 1 to 100 years using this. So number of years in range 100, correct? 1 to 100. Number of leap years in the range 96 divided by 4. Remember how many you got? 24. So this gives you immediately the answer 124 odd days. Then of course you can divide it by 7 and get to the 5 odd days. So this is 5310. Now from 1 to 400 you reach 0 odd days. Don't you think after this, if I, so that means if I start counting from 401 year, it actually does not matter what happened before. Correct? Because now I got to 0 odd days. Correct? So now I am just starting as it is. So ultimately, if you find out, so 1 to 500 years, if you find out, it actually starts repeating. So it is again 5 odd day. Then 1 to 600 years is again 3 odd days, and it goes on like this. 5310, 5310. This is the pattern. 5310, where 0 is for century leap year. Example 400, 800, like this, etc. So 5310 is what you have to remember. This is the number of odd days in a given year range. Okay. Now Now, if you understand this, can you tell me in the first, from in the first, like this, from the start I'm always counting, from the start I count. So I ask you that in the first 1600 years, how many odd days you get? In the first 1600 years, how many odd days? Correct. So it will be no odd days. Why? Because it will be divisible by 400. Correct. So century leap year is there, that is 1600. 1600 you will get 0 immediately. Now if it is first 1900 years, then what will be the number of odd days? So you understand 1900 is what? 1900 is again 1600 plus 300. Now 1600 will leave odd day or remainder 0. What remains is 300. Now for the first 300, what you got? 1 day. So basically here the number of odd days will be 1. As simple as that. What you have to do, you see any random year. For example, let's take one more. Let's take 2300. Now what you will do, you will divide it like in multiple of 400, the nearest multiple of 400 plus whatever is there. So you write here 2000 plus 300. For 2000 it will come out to be 0, correct, divisible by 400. For 300 you remember that it is 1. So only this you have to remember, that for 100 years 5, for 200 years this is 3, for 300 years this is 1, and for 400 years it is 0. And then you get to the answer. Understood? Now just one last thing and then we can start solving for the real days. Now, so in the Georgian calendar, the 0th day or the reference day is always Sunday. Cause on first, when the calendar started 1101, okay, then the day was considered as Monday. So 0th day is actually Sunday. So that means whatever is the number of odd days that you get after solving, you have to add in Sunday, and that gives you the answer. And that will give you the answer. That means what? That means if you got eventually after solving, after doing everything, after solving, if you got 1, that means the day was Monday. If you got 2, that means it was Tuesday. If you got 3, it was Wednesday. If you got 4, it was Thursday. 5, that was Friday. 6 means Saturday. 7 means, now 7 odd day you cannot really get, correct, because 7 by 7 will again give you 0 remainder. So what you will get is 0. So if you get 0 odd days, eventually the day is actually Sunday. Okay, why? Because you're adding 0 to Sunday, you get Sunday again. So this is what you will get. This is also how you usually do. You count Monday as 1, Tuesday, Thursday, like this. That's why you count it like this. Understood everything? Anybody has any doubt till here? Please tell. Then we'll understand how you start solving questions like these. For example, starting with 15th of August. Then, fine, everyone? Okay, okay. Now let's find out for the 15th of August. So 15th of August 1947. 15th August 1947. Now, let's try to find it out. So basically, the pattern is this. We always start, if we have to calculate day on a real date, then we always start from the start of the calendar. That is 1 AD, okay, whatever. So from that we will start. Now, how do you get to this date? That is 15th August 1947 from that initial calendar. So let's try to reach it. Now, I start from the first day of the calendar. First, I will try to reach the nearest century year. That is done. So what I'll get to? I will first get to 1900. Can you feel this? I am going from 1 to 1900. Correct. Now, if you take 1900, then how many odd days you will get because of 1900? This we have already calculated. This goes like 1900 is equivalent to 1600 plus 300. Now this gives 0 odd days and 300 gives 1 odd day. So that means you get 1 odd day because of going to 1900. Now you have reached 1900, correct? Now we will look for 1 January 1901 to this point, correct? Now again we'll break it down. So next thing, we try to move to first whatever year is completed. So 1900 was done till here. Now from 1901 we will move towards the last year that got completed. So I go from here, which is 1901 to 1946. Correct? This is the completed year. This I have to count completely. Correct? So now let's count this. Now for this range, that is 1901 to 1946, complete from 1st January 1901 to 31st December 1946. Now how many odd days do I get here? How many odd days? So if you remember the formula, it was number of years in range plus number of leap years. Now you do it. So basically what it becomes, number of years in range. How many years? 1901 to 1946, 46 years. So this is 46 plus number of leap years. How many leap years? What is the nearest leap year that you can think of here? Isn't this 1944? Correct? 1944 is the last leap year in this range. Now simply 44 divided by 11 gives you what? Sorry, 44 divided by 4 gives you what? 11. So that means how many leap years? 11 leap years are there. So plus 11. So 46 plus 11, what you get to? You get to 57. This is fine. 46 plus 11 is 57. Now 1901 to 1946, how many odd days you are getting? 57, but you don't like 57 for obvious reasons, correct? So you will want to divide this by 7 and then get to the odd days. So 57 by 7, what you get? You get 1 as a odd day. So how many odd days? 1 odd day again. Fine till here. Now where you have reached? You have reached 1946. Now 46 is done. Now where I have to reach? I have to reach 47. Correct? 1947 I have to reach. Starting from 1st January, I have to move to 15th of August. Now see this. So I start from now 1st January 1947 to 15th of August 1947. This is what I am trying to do. 1st January 1947 to yes, Friday is the answer, Amit. Then 1st January 1947 to 15th August 1947 is what I'm trying to go. Now let's start counting it. So I took January, February, March, April, May, June, July, August. Now, I put a hash mark here because conditions apply. Now, let's start counting the number of odd days directly. So January, how many odd days? If you remember, you have to subtract 28. So how many you got? 3 here. Then what kind of year is this? 47. 47 is a normal year. So that means in Feb, what you will have? In Feb, you will have 0. In March, how many? You will get 3. In April, 2. In May, again 3. In June, 2. I'm just subtracting 28 from it. Then in July, you will get 3. In August, some people start writing 3. This is wrong. Why this is wrong? Because this 3 is what you got for the entire August month. But entire August month, you don't have to go. You have to only go till 15th of August. So that's why instead of 3, you should be writing 15 here. That is the day that you want to get to. Now you have to simply add it, divide it by 7, get the number of odd days. So let's add it. 3 plus 3 is 6, 6 plus 2 is 8, 8 plus 3 is 11, 11 plus 2 is 13, 13 plus 3 is 16, 16 plus 15 is equal to 31. Correct? Now 31 by 7, again I am dividing by 7 to get the number of odd days. So 31 by 7, what do I get? 3 is the number of odd days. I have started from the initial 1st January of the calendar when the calendar was made, and I have come to 15th of August 1947. How many odd days are there? 1 odd day, 1 odd day, and 3 odd days. How many odd days? 3 plus 1 plus 1. So total odd days will be sum of all these, which will be equal to 1 plus 1 plus 3. That comes out to be 5 odd days. Now if there are 5 odd days, what is the day? You remember the reference is what? The reference is always Sunday. 5 means Friday. So the answer becomes, what day was it? It was actually Friday. That is Jumme ka din. Okay. Pakistan was in too much hurry to take independence. They didn't even wait for Friday. So on 14th of August, they declared independence. Okay. Now, so this is the day. You understood the entire process? Yes, Amit. Yes, you can directly write it also. Like Amit is saying, you can take 15, 15 divided by 7. Here you can directly write 1. That is also possible. Some people like to do what? That they just start cancelling out multiples of 7. Correct? So you see 2 here, you see 2 here, and 3 here. Wouldn't they come, if I add them together, 2 plus 2, 4, 4 plus 3, 7. So they will eventually make 7, and 7, you can just remove 7. 7 does not matter. So they will just mark it round and cancel it. Won't even count it. Those are many different ways you can do it. I have done it in the way that the most simple way, that is you have add them all, divide by 7, get the number of odd days. This is the entire process. You first take the century, year that got completed, then you get to the year, the last year that was completed, then you get to the months and date. This is the entire process. Of course, you won't be writing it like this. We'll do it in a much faster way. Anybody has any doubt, then they can tell. Anurag, just wait. Okay. When we'll do the PYQs, you'll see it does not take much time. Now, let's try to do this. Which day is 10th October 2027? Tenth of October 2027. Okay, now see how we will be doing this in exam. So first thing, what I see, 2027. First I will write the century years that is completed. What is the nearest one? 2000. Correct? Now 2000, what number of odd days it will give? Nothing, 0. does not matter. Then next I get to the number of years that are completed. How many years are completed? 26. Correct? Now remember that how many odd days you had. If there are 26 here, if you count from 1 to 26, how many odd days are there? So first is the time range, that is 26, plus the odd number of leap years. How many leap years you have? Nearest is 24. 24 by 4, what you get? 6. So what you can do, you just write the number of years completed here, and with this only you write the number of leap years within it. Correct? So how many leap years? You have 6 leap years, so plus 6. Fine till here. Now you have done till 2026. Now you try to get to 2027. How you will get to it is like this. So Jan, Feb, March, April, May, June, July, August, September, October. Now, how do you do this? So you start writing whatever months are completed. So January is completed. So this is 3. Then this is 2027. So normal year, that means 0, then 3, then 2, then 3, then 2, then July is again 3, August is 3, September is 2, but October is again hash. I don't have to count it fully, so I count it 10 here. Fine. Now see, one more way you can use this is you just start creating multiples of 7 and cancel them out. So you see here 2, 3, 2. You can cancel this out because ultimately you will be adding all of them. So this becomes 2 plus 2, 4, 4 plus 3, 7, gone. Then you come here, so you see here 3 plus 3 plus 3 plus 3. What is this? This is 12. 12 plus 2 is 14. Can you see this? You can cancel all of it. Now see it again, see it again. Won't take much time. See, 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 2 is 14. Is 14 a multiple of 7? Yes. Cancel all of them out. What remains is 10. Now 10 divided by 7 is very easily, the remainder is 3. Correct? So how many odd days you got? You got 3 odd days from here. Now let's look for, this is 0. 26 plus 6 is what? 32. Correct? 32 by 7. What is the number of odd days? 32 by 7. Clearly 28 is the nearest multiple. So remainder is what? Remainder is 4. So from here you get 4 odd days. So you got 4 plus 3. How many odd days? You add them together, you got 7 odd days. But there is nothing like 7 odd day. Actually, you will have to divide it by 7 again to see the remainder. The remainder comes out to be 0. That means 0 odd days. Now, if it is 0, what is the answer? If it is 0, what is the answer? 0 is for Sunday. So that means 10th October 2027 was Sunday. Yes, Neelam. Yes, Amit. Yes, Anurag. Okay, so this is how you have to do it. Immediately write the century year which is completed, then the total number of years in the range that are completed. From this only you can write the number of leap years within it, and then this method, that is, you're creating multiples of 7 and just cancelling them out. It will become much quicker. Okay, then now let's move forward. Yeah, find out this. Which date of June 2099 among the following is Sunday? You need to find Sunday. You can take any. So what you can do, you can just pick any and start finding out for this. Let's say you're trying to find out for 5 June 2099 is what? Try to find this out. Find out for 5 June 2099. Okay, so it is like 2000, sorry, this is not 99, this is 98. Always be careful, this is the number of completed years. 2099 is not completed. So 2000 plus 98 plus 24, how I got? Nearest multiple of 4, 96. 96 by 4 is 24. This gives me the number of leap years. Number of years plus number of leap year, this gives me number of odd days. Correct? Now, this is January, February till I have to go till June. Now, first thing 2000 gives me 0. Then 98 is also a multiple of 7. If you know, 14 sevens are 14 sevens are 14, 14 fives are 70, 14 sixes are 84, 14 sevens are 98. Also gone. Then what is remaining? 24. 24 leaves remainder 3. So from here you got 3 odd days. Now let's calculate for this January, February and all this. Now Jan is what? Jan is 3. What kind of 2099? So a normal year 0. May is 3. April is 2. May is again 3. June I don't have to count fully. What I'm trying to find out? I'm trying to find out, let's say 5th June. So I count only 5 here. Now I can add 3 plus 3. 3 plus 3 is 6. 6 plus 2 is 8. 8 plus 3 is 11. 11. 11 plus 5 is 16. Correct? Now 16 divided by 7, what is the remainder? 2 is the number of odd days. Now if 2 is odd days here, 3 is odd days here, total how many odd days? 5 odd days. 5 odd days means what? 5th June is what? 5th June is Friday. If 5th June is Friday, then it is asking you which among them is Sunday. So 5th June is Friday, 6th will be Saturday, 7th will be Sunday. So answer becomes 7. 7th June will be Sunday. Yes. Yes, Amit, correct. Yes, Anurag, you can do it by 2100 also, but then you have to move back. Okay, that is another kind of process. If you are comfortable in it, you can do it using 2100 also, but you will have to go back. You have to remove those months. Okay, then this we have already done. Now we get to the other part, which is the referential date questions. Okay, now one honest confession. So basically, the referential date question is important for other exams a lot. Okay, in UPSC they have not asked many questions from this. Okay, they have mainly asked from real day on a date, and then the last topic, that is calendar repetition, that they have asked multiple times. This they have very rarely asked. Okay, so we try to understand the concept, but we won't do a lot of practice of it. Okay, now first thing, see what is the difference. So referential date questions is where some date and day pair is given to you. Now this may be true as per the calendar, maybe, or this may be false as per the calendar. Both are possible. Correct? For example, ideally, what day is today? Today is Wednesday. On 1st April 2026, it is Wednesday. Now, if I tell you that 1st April 2026 is Sunday, now you have to tell me that on 7th April, what is the day? Correct? So reference actually changes completely. That is why in referential date question, you cannot apply the old method of finding the real date. Correct? So now look here. So first it says that 14th of February 2023 is Monday. Then 14th Feb 2024 will be what? This is the question. What it will be? What do you think? What do you think? Anurag, it will not be asked like this. If it is asked what will be the first day of the week, it is not usually asked, but if you have to take, you take Monday. And then 14th Feb 2024, what it will be? What do you think? Yes, only one odd day you have to add. Why only one? Because see, 2024 is a leap year, but you need to understand that leap year is counted only when 29th of Feb is in range. Because if you don't cross 29th Feb, it does not matter if it was a leap year or a normal year. Every other day is the same. So now if you look here, 14th Feb 2023, you move to 14th Feb 2024, you are actually not crossing 29th Feb, which only comes in 2024, not in 2023. So that means this is like a normal year till now. So you just have to add one, Monday plus one, this becomes Tuesday. Now can you tell for 2025 what it will be? For 2025, what you will have to do? Now it will cross 29th of Feb 2024. Correct? Now it will cross it. Now, because it will cross it, so this is like a leap year now. So now instead of one, how many odd days you have in a leap year? You have 2 odd days. So you add 2 here. So Tuesday plus 2 is Wednesday, Thursday. So here the answer becomes Thursday. Understood? So always what you have to look, you are habitual of counting number of years in range plus number of leap years. Now here you have to be careful that in leap years we only count it as leap year or count one extra day when it crosses 29th Feb, not otherwise. Fine. Yes, Anurag. Yes, Saundarya. Saundarya. Yeah. Then now let's see this question. See, in one question only we'll understand everything. See, you have learned how to calculate odd days and the range. Now it is nothing. Okay, the process is fairly simple. So 24th of September 2009, this is 30th of December 2014. It is asking you if this is Thursday, what is this day? Now, first thing, always make a note that whatever we have to do with the leap year, whatever, we do it in this year part itself. We don't deal with it in the months. In our months we take it very simply. Okay, so in our months when we are calculating between months, we always consider it like a normal year. Does not matter to us if it was a leap year or not. That we deal with here. Now first thing, you see that you have to move from 2009 to 2014. That is in the positive direction. Correct? Now can you find out, forget the date for now, forget the dates for now, can you find out between 2009 and 14 how many odd days you will get for the same date? So 2009 to 14, if you look, how many years in total? Number of years in range, this is 5. Correct? 14 minus 9 gives you 5 plus number of leap years. But which leap years do I have to count? Only ones which is covered in which 29th Feb is counted. Now which is the leap year? 2012 is a leap year. Is 29th Feb of 2012 there? Yes. Then no other leap year. So I have to just add 1. 5 plus 1 becomes 6. Correct? Now we are done for the year. Now we come to months. The process is fairly simple. See, it does not matter if you go from September to December, December to September, whatever. We always write it in the same order so that we don't get confused in the exam. So you start from September, you go to December. This is the normal order. We'll see that whatever direction, sign, that we'll see later. Right now, you have to go from September to December. Of course, this is also positive. So you start moving. So this is September, October, November, December. Now this time we have hash on both sides. Why? Because not all days of September are in the range. How many days are in the range? So if September is of 30 days, 24 have already passed. How many days are remaining? 6 days. So only 6 will be counted here. Of October, how many? Now October is completely within the range. So how many odd days you have in October? In October, you have 3 odd days. Then in November, you have 2 odd days. In December, again, you won't count the entire thing. You have to only count till 30. Correct? So here I write 30. That's it. From here I will calculate the number of odd days. So it becomes what? 6 plus 3 is 9, 9 plus 2 is 9 plus 2 is 11, 11 plus 30, 11 plus 30 is 41. Correct? Now, if I divide 41 by 7, what is the remainder? 41 divided by 7, this gives 6 as remainder. 35. Correct? Now, you got 6 as remainder. Now, 6 plus 6. Correct? 6 plus 6 gives you 12. But 12 cannot be the remainder. Remainder has to be less than 7. So 12 by 7, what is the remainder? 5. So that means there are 5 odd days that I need to add. Now it is very easy. Thursday plus 5 is what? Count it. Thursday, then Friday, Saturday, Sunday, Monday, Tuesday. So answer becomes Tuesday. That's it. As simple as this. No Sandhya. 2 word days. No Anurag. Okay, so what you got? You got Tuesday. Understood? Now, so you always calculate year separately and days and month separately. Okay, let's see this. Let's see this first. This is like a similar question that we learned. Only two things you have to remember. One is you always count the leap year only in the year. The other thing was that you have hash on both sides. Correct? Now, let's do this question. So it says in a particular year, 12th January is Sunday, then which of the following is correct? So the question says that 12th of January is Sunday. 12th January is Sunday. Then it is asking you that 15th of July is Sunday if it is a leap year. 15th of July is a Sunday if the year is not a leap year. 12th July and 12th July. Same thing. Leap year or not leap year. So if I have 12th Jan here, let's try to find out what will be 12th of July. This is the only question from referential date question that we have directly seen. One more is there, but that is much more normal. Now, 12th July I want to calculate. 12th January is given to me. Okay. Now, according to the question, there are two possibilities. One, if it is a leap year and if it is a non-leap year, or let's call it normal year. Correct? Let's try for leap year what we are getting. So now for leap year I am moving. Okay, I am starting from January and I'll move till 12th of July. Now see, so I count Jan, Feb, March, April, May, June, July. I have two hashes on the both sides. Now January, how many days are remaining? 12 are gone, 31 days in total. 31 minus 12, what I get? 19 days are remaining. Now here is the twist. Because we have taken leap year, I have to count 1 for February. Correct? So I count 1. So 19 plus 1, then I'm just writing the numbers right now. So 19 plus 1, then March is what? March is 3, April is 2, May is again 3, June is 2, July is, now July again I have to only count till 12 days. Correct? Now let's add them together. So it becomes what? 19 plus 1, 20. Correct? Then 20 plus, or you can just cancel out. See, 2, 3, 2. Again I can cancel out. Okay, 2, 3, 2 is gone. What remains? 19 plus 1, 20. 20 plus 3 is 23. Then 23 plus 12. So it is actually 23 plus 12. What you get? 23 plus 12 is what? 35. Oh, 35 means what? 35 divided by 7. What is the remainder? 0. Now, what does the 0 mean? That in Sunday, I have to add 0 odd days. If I add 0 odd days, what it will get? That means 12th July in a leap year is also Sunday. Is there any option like this? Yes. 12th July is Sunday if the year is a leap year. This is very clearly the answer. Now, if you would have taken the normal year, what you would have gotten is one less year. Correct? You would have gotten one less year. So that is instead of this 35, you would have gotten one less year. Correct? This one won't be there. So you would have gotten 34. Then if you would have divided 34 by 7, you would have gotten 6 odd days. Now, if you add 6 plus Sunday, what is the day you will get? You will get to Saturday. So then the answer would have been, if it is a normal year, then 12th July is Saturday. If you started with this, then you can just, it can click your mind immediately that if I had one more odd day, I could get to Sunday. And that is what you get from a leap year. So that is why in this, I just randomly tried and it came suddenly same as Sunday again. So that's why the answer becomes C. 12th July is Sunday if the year is a leap year. Saturday, Friday, Tuesday. Don't know which answer is this on the there. Okay. Then let's try this. This is fairly easy. Simple reasoning. It says if second and fourth Saturdays and all the Sundays are taken as the only holidays for an office, what would be the minimum number of possible working days for any month of any year? Think what kind of year and what kind of month you would like to have minimum working days. If you are working, of course you want minimum working days. Yes, non-leap year, correct, Saundarya. Which month you would like to take? Which month you would like to take? So you would want to take the month which has least number of days. Correct? Least number of days. So basically you will take Feb of a normal year. Feb of a normal year has how many days? It has 28 days. Now, according to the question, second and fourth Saturday are holiday. Now every month has all the days at least 4 times. We have seen that in that question, correct? So every month has 4 of all the days. So now second Saturday is gone, then fourth Saturday is also gone, and 4 Sundays that must be here that are also gone. So 2 plus, so basically 2 days are here, 4 days are here. How many days you can subtract? Maximum 6 days can be holiday. So minimum working days will be what? It will be 28 minus 6, which is equivalent to 22 days. So answer becomes B, 22. Yes, Saundarya, Feb. So answer becomes 22. Understood? Fairly simple concept. Now we get to the last part. This is very easy also, but it has seen many questions. This is simple calendar repetition. The formulas or whatever you want to call it is very simple. If it is a leap year, you just add 28. So basically, see, the concept is that since the start of the calendar till now, of course, you don't have a different calendar each year. Correct? You will only have, after few years, you start having the same calendar. For example, the calendar that you have in 2025 is same as the calendar. Sorry, let's take another example. So let's take the calendar that you had in 2005. 2005 is same as the calendar in 2011. Okay, if you want, you can look. If you want to see 2005 calendar, it's same as 2011 calendar. So basically there is repetition of calendar. Now they ask you questions based on, let it be, based on if, what if this particular year will have the same calendar next in which year. Now there are four kinds of year that you can have. Either it is a leap year, correct, or it is a leap year plus 1, or it is a leap year plus 2, or leap year plus 3. These are the only possible things. If you do leap year plus 4, what you get? Leap year plus 4 is again a leap year. So that's why that is not possible. So leap year plus 1, leap year plus 2, leap year plus 3. Now, if it is a leap year, you add 28, you get the same calendar. Now, if it is leap year plus 1, you have to add 6 and then you will get the same calendar. And if it is L plus 2 or L plus 3, you have to add this and you get the same calendar. Okay, you can find out for any of these. For example, let's say you're trying to find out for 2019. Can you tell me for 2019, next year, when it will have the same calendar? Yes, Soundarya. 2019, when it will have the same calendar? So basically 2019 is what kind of year? What is the, this is like L plus 3 kind of year, correct? L plus 3, can you feel this? Correct. Why? Because if you see 2016 is a leap year, then 2017, 2018, 2019. So this is L plus 3. What you will have to add? You will have to add 11. 2019 plus 11 gives you 2030. This becomes the answer. Simple, no issues, correct? Just you have to remember these three figures. Add 28, add 6, add 11. Actually, this is coming from the concept of odd days. Once the number of odd days becomes 7 or multiples of 7, that many years you can add to get to the same calendar. Correct? Now, let's do some PYQs. Very easy. Which year has the same calendar as 2009? Find it out. Yes, Soundarya. Find it out. Same calendar as 2009. 2009 is what kind of calendar? Isn't this L plus 1? Huh? Isn't this L plus 1? Why? Because this is like 2008 plus 1 year. Correct? So this is like L plus 1. In L plus 1, what you do? You just add 6. So you add 6 here. 2009 plus 6, what you get? 2050. So answer becomes D, 2050. As simple as this. Now let's do this. Which calendar has the, which year has the same calendar as 2025? Same calendar as 2025. Again, this is what? This is very clearly 2024 plus 1 or L plus 1. If it is L plus 1, what you have to do? What is the thing? You add 6 to it. In L plus 1, you just simply add 6. So you add 6 to it, what you get? 2031. That's it. This is the only thing you have to remember. And all questions, they were more similar in 2011 and all, that I didn't keep. Simply you have to add 6, 11 or 28 depending on what kind of year it is. Okay. Now, this is the last question. This is not really calendar, but this is what they gave in 2025, a mix of calendar and series. Try to find out the pattern because we have also done number series as well. Try it, try it. This is the last question and then we'll be done with the session. Yes, Vakiresh. Yes. Yes, Soundarya. What comes at X and Y respectively in the following sequence? Jan, December, October, X, March, October, Y, September. What do you think? See, the pattern is fairly simple. Okay, what is the pattern? So this is January, this is January. What I'm doing? I'm adding actually 0 to it. The difference between them is actually 0. Then January to December, January to December is what? You are subtracting 1. So this is minus 1. Then this was minus 0, then minus 1, then this should be minus 2. Is it minus 2? Yes. December minus 2 is what? December minus 2 is November, October. Then the next would have been October minus 3. October minus 3 is what? October, if I write it, Jan, Feb, March, April, May, June, July, August, September, October, November, December. So this is October. October minus 3. So 1, 2, 3. What I get to? What I get to? I get to July. So this is July. Correct? Now, next is from July. Can I go to March? Yes. This is minus 4. Correct? 1, 2. Yeah. So this is the pattern that it is following. Now similarly, if I try to find out the value of this y, March, October, it yeah, sorry. Then so what you get here? You get here July, and then what you have to go? You have to go minus 4. Then similarly, you keep going here. From October, you get to y, which is April. Okay, so you get to the answer, that is B, July and April. Who got it correct? Yes, yes. Saundarya is correct. Yes, Anurag is also fine. 9 and 6. Yes, most of you are getting this correctly. With this, we are done with our topic of calendar. This is what we started with. These are the three kinds of questions that we usually get. One is just the simple ones, okay, like these, and finding out the real d. This is the most important part, that is you find out the real day on a date. Okay, then after this we learnt about referential questions. This, yeah, referential date questions very rarely, but you understand the process. So if it comes, you can do this very easily. You just have to remember that you have to put hash on both sides, that you have to look for both the ends. Then at last you had something known as calendar repetition, which is fairly easy. If it is a leap year, add 28, leap plus 1, 6, and otherwise add 11. Okay, slightly long session today. Actually, this is a much bigger chapter. That's it. And we end the session. Any doubts? Anything? Yes, Anurag, correct. Okay. Okay, thank you.